Hey everyone, and welcome back to the final episode in our Python data analysis series. In this episode, we're going to try and piece together everything we've learned to find a new dataset and do some data analysis on it. Since we've already performed all sorts of basic analysis on our AI global index dataset, let's find a new one on Kaggle so that we can all go through a new dataset together for the very first time. After doing a little bit of searching, I found a dataset that I think would be interesting for us to use. Instead of an AI global index for the world, it's a world happiness index. It ranks each country in terms of how happy the average citizen is and has variables like economy, health, family, freedom, and more that might give us some insights into how these general factors for a country might impact how happy its citizens are. I'll put the link to this dataset in the description below if you'd like to work alongside me in this video. Once you have this downloaded, let's hop right into our code so we can start exploring. So the first thing we want to do is import all the libraries we're going to be using so we don't have to worry about adding them later on. If for some reason we miss some of them, we can always add more to this first code block. So we know we're going to need to upload our file, so just like the other episodes, let's add a Google Colab import here. So we'll say from google.colab import files. And then we also need to import IO to read the file, so I'll just say import IO. And then we'll need to get our most valuable library, which is Pandas, so I'll say import Pandas as PD. Next, we're going to be doing some plotting using material plotting library and Seaborn. So let's add those two imports. So for material plotting library, we'll do the same as before, and we'll say import matplotlib.pyplot, and then we'll also do import Seaborn. Got that wrong. Import Seaborn as SNS. And then after that, we're going to be using Numpy for our regression arrays. So I'll also add a Numpy import. I'll say import Numpy as MP. And then for the very last import, we need to import some modules from Sklearn to actually do our predictive modeling. So I'm going to import individual modules from this. So I'm just going to write from sklearn import, and then we'll do the same ones as the last episode, model selection, and also linear model. So model selection is the module used to put up the training and testing sets, and then linear model is the module to actually build a linear regression, just for a quick review from last episode. So I know this might be kind of a bit confusing or overwhelming at first to have all these libraries kind of here bunched up at the very top. But now that we've got them all ran in one block, it'll be nice so we don't have to worry about it later on in our code having to add libraries as we go. So under all these imports, we'll make a variable. Let's just call it data file, just like we did the first time. And then we're going to set it to equal to files.upload. And then this will obviously call our upload function from Google Colab to upload our CSV file. And then right underneath this, let's make another variable. Let's call it df. And then I'm going to copy and paste this line here. So this line is the exact same line we use to actually read the file for our AI global index, except the only difference is that it has its title changed, so now it's just World Happiness 2016.csv, which should be the name of the file once you download it from Kaggle. Okay, so I went ahead and just ran this code block and then selected the World Happiness 2016 CSV file, so now we should be good to go. So the first thing I usually do with a new dataset is just see what it actually looks like. So let's just call a function here. Let's say df head, and let's just pass in 10 for this so we can see the first 10 entries in the dataset. And voila, here's a dataset. So this is what it actually looks like. We have many countries of the world, and they're by default ordered by their happiness rank, with Denmark being 1, Switzerland being 2, Iceland being 3, and so on. And right away, before even looking at the other variables, we can see that all the top 5 happiest countries in the world come from Western Europe, which may be an interesting thing to explore in just a little bit. If you look beyond just the rankings, you can see the actual happiness score that each country is ranked with. So obviously a higher score correlates to a lower numerical rank. Then you have lower and upper confidence intervals here, which for a more complex analysis may be helpful, but since we're doing a kind of a more basic analysis for beginners, we're probably not going to be using these columns a whole lot. After that, we just have a couple of variables to look at that could be correlating variables to happiness. So we have economy, we have family, health, freedom, trust, generosity, and dystopia residual. These all appear to be based on a scoring system, but it's not immediately obvious to me what scale they're based on. Some look like they're based on a scale of 0 to 10, and others look like 0 to 1, and some look just somewhere in between. So purely out of curiosity, I'm going to go ahead and just make a new code block here, and I just want to see the bottom 10 entries. So I'm going to do df.tail, and I'll just pass in 10 like this, and then we'll take a look. So if I run this here, these should be the 10 unhappiest countries in the world generally, with the bottom few being Togo, Syria, and Burundi. So these countries all fall in Africa, which may be another interesting region to explore in a little bit. So now let's try and get a better idea of what our dataset actually is. So you've seen it now, but let's look at some descriptive numbers to get us a better understanding. So I'm going to make another code block down here, and we're just going to call our df.describe function that we've done so many times before, just to give us a quick summary of the dataset. So if we run it, we'll see that we get a nice summarized table of all its attributes. So it looks like there is 157 total countries in the dataset because each column has 157 entries within the, the count variable here. Let's keep in mind that there are, I think, approximately 195 countries in the world at the moment. So there are a fair chunk of countries that aren't actually on the dataset and don't have data collected for them. So we are missing a decent amount of countries. So can you just keep that in mind? Let's look at some mean values here for a minute. So it looks like if we look at the mean overall happiness score for the entire world, it's about 5.38, which should, somewhat make sense if the scale is from 0 to 10. So let's look at actually the min and max of happiness. So it looks like the min, so the min here is 2.90 for happiness score, and then the max is 7.52. So it's probably likely that the scale is out of 10. Then of course we have the percentiles in each field. So we can look at like 25, 50, 75%, things like that. So just for example, with our percentiles, it looks like to be like in the 75th percentile of happiness, you have to have a score of at least 6.269 or above. And then to be, if you want to be in the bottom 25%, you got to have 4.405 or below and so forth. If we look at the min, especially in the fields like economy, family, health, and freedom, it looks like a lot of these, actually pretty much all of these, have a minimum score of 0, which shows that there are some countries that for certain measurements are at the absolute lowest possible value they could be at. So next, I know we can see all of our column titles already, but let's quickly print off a list of our column titles because I want to see them as strings because it looks like some of them are kind of long here, especially the ones that have like parentheses here like this. I just want to take a look at what the actual like string values are. So I'm going to type df.columns just to get the column titles and then run it. And then, so it prints out an index list of all the names. So we have country, region, yada yada. So just looking at this, I can already see it definitely might be a big inconvenience for like fields like economy, where there is parentheses here, having to like type everything out with parenthesized text. Because if I want to access the economy column, I don't want to have to type economy and then parentheses GDP per capita. It'd be nice to just type, just economy by itself. And then same goes for like health here, also has parentheses in it. And so does like trust and those other columns. So to fix this, let's actually change some of these column titles. So I'm gonna make a new code block down here where we can call the rename function. And actually first, I'm gonna make a copy of our data set just so we don't corrupt the original data. So let's make a new variable. I'm just gonna call it dataset. And again, this is not like the greatest naming scheme. I'm just kind of doing it for the sake of this video. I'll say dataset equals df.copy like that. And then I'm just gonna run this just so we have it now. And now we have our copied dataset. So I'll make another code block after this actually. And then I'm just going to write dataset.rename. And then inside, we're going to want to specify what we're renaming. And that's going to be columns. And then what do we need to do here? If we look at the Pandas documentation for the rename function, it wants a dictionary of key value pairs for each column, where the key is the old title and the value is a new title. So it should look something like this. So we'll have squiggly brackets to signify a dictionary. And then for the first key value pair, let's do health. We'll say health, parentheses, life expectancy. I believe there's a space here. It looks like there's a space. Yeah, okay, there's a space there. Okay. So do health, life expectancy, and then we just want to change that just to say health. And then let's do, next we'll do economy, which is space GDP per capita. I believe it's, okay, yeah, making sure. So the P is not capitalized, but the C is. So we'll do this, and then, oh, I messed up there. GDP per capita, and then we'll say rename it just to economy, so we don't have the extra radius stuff. And then lastly, I want to do the trust column, so I'll say trust, and that's government corruption, like this. And then I want to have that replaced with just trust, like this. And then I want to modify this data set directly, so I'm going to add another argument here. I'm just going to say the in place argument. I'm going to say in place equals true after I pass in the columns argument. So then if we actually run this block, we should now have a data set with the columns renamed to be simple titles instead of having parenthesized text. So just to show you what the new thing should look like, let's just print out head of dataset. So I'll do datasets.head like this. And now if you look at it, we've now replaced our columns with some simpler names that aren't as hard to type. So economy, which was economy GDP per capita, is now just economy. And then health is, just health now, then trust is just trust, and so forth. So it's a little bit simpler and a little bit nicer to read. So one more thing I want to do with this data set in terms of kind of just getting it cleaned up is I want to drop some of the columns. So I mentioned that we're probably not going to be using these lower confidence and upper confidence interval columns. So let's just go ahead and get rid of these columns to make the set easier to look at. So actually in this same code block, I'm going to go actually make a line here. I'm just going to call dataset.drop. I'm going to say dataset dot drop. I'm going to pass in a columns argument. And then we're just going to want to pass in a list of the columns I want to drop, which is just going to be 2 of them. So I'll say lower confidence interval, comma, upper confidence interval. And then, again, we want this to be modified directly. So I'm going to say in place equals true like this. So I went ahead and ran this chunk, and you can see now that it looks quite a bit nicer since we have obviously our column titles replaced, and now we drop the 2 extraneous columns that we're not really going to be looking at throughout this episode. Now that we've done a little bit of data cleaning, I want to take a look at some statistical analysis information. So I want to look at like the mean, median, and standard deviation of some of these columns. So we already did a little bit of this earlier with our describe function that we have here, but I want to actually just look a little closer at this. So I'm going to make actually, let's say 3 new code blocks for each function. So I'm going to have like one of these blocks. I'll have this as the mean block, median, and standard deviation block. So in these functions, we want to select only the numerical columns, or else like last time, we'll get a warning that we're trying to calculate the mean on things that aren't actually numbers. So in this first code block, let's just write, let's say datasets.lock. Then we're going to select everything from, we're going to select every single row and then every single column from happiness score all the way till the end like this. And then we're just going to call the .mean function on it like this. So we could specify dystopia residual here in this thing like this. Like we could type dystopia residual, but it's actually not necessary if we do nothing after the colon because it'll just autofill to the very end. So we don't actually need it because it'll go to the end of list like this. And then before I run this, let's actually copy this line here. I'm going to paste it into these 2 blocks here, and I'll just change these. So this will be median, and then this one will be STD for standard deviation. And then I'm going to run all these blocks. So I'm going to run the mean block here, run the median block, and then run the standard deviation block. So for instance, looking at the mean, it looks like the average happiness score is 5.38. The average freedom score, for instance, is 0.37, and so forth. So it definitely helps to see all the means side by side like this, as it helps to give us kind of an idea of what the range of the numbers kind of looks like in each of the columns. And then as expected for looking at median, the median numbers are actually fairly close to the mean numbers. As we know, the median is just the middle number in a list in sorted order. And then lastly, of course, we have our standard deviation scores for each of our variables. Which, if we're looking at this right away, it's obvious that happiness score is the most variated out of all the variables. So next, I want to do a little bit of selection and sorting to get an idea of what the highest and lowest of some individual fields might be. I want to make a new code block actually right here, where we can go ahead and do this. So let's first select the country and happiness score columns and sort them in order of highest to lowest happiness scores. To do this is pretty simple. But first, I'm going to select these 2 columns. I'm just going to write, let's say dataset, and then pass in a list here. I'm going to say country, and then comma, happiness score like this. And then we want to call this function sort values. And then we're going to sort it by, let's say happiness score. And then we're going to do ascending equals false. And I'll explain what all these mean in just a second, so bear with me here. And then I'm going to say dot head like this. And then if we run it, you'll see we have Denmark, Switzerland, Iceland, Norway, and Finland here at the top. And then we have Benin, Afghanistan, Togo, Syria, and Burundi here at the bottom. So basically what this line is doing here, let's break it down step by step. So all I'm doing here is selecting both the country and happiness score columns, and then I'm calling this function that is called sort by, and then it'll basically sort a list of entries in order based on a certain variable. So I'm just saying sort by the happiness score, and then we're going to pass in ascending equals false. If I did ascending equals true, it would actually do the opposite of this. So it would show these ones at the bottom here first, because this is actually technically ascending. If we're starting here, this is the lowest number and this is the highest value, so it's ascending. We want it to be descending, so hence why ascending is equal to false. And then we're just doing dot head, which obviously will print out the first 5 entries. And I actually didn't realize I made a little quick fix there of putting the parentheses here. I guess if you don't put the parentheses there, it prints it off like this in kind of an ugly way. But if you do a parentheses, it makes it a little better, just like this in our regular table format. So I want to look at actually now the bottom 5 countries like we just did. However, I want to do it in this kind of similar format. I'm going to make a new code block here. I'm just going to copy and paste this. And instead of dot head, I'm just going to fill this with dot tail like this. So if I print this off, as we saw before, the lowest countries in here are Benin, Afghanistan, Togo, Syria, and Burundi, with the lowest score being 2.905, which is the lowest score in the whole list. So we already knew this from our original tail call, so let's actually look at more variables besides just happiness score. So to look at some other variables, let's make a new code block here. We're going to do kind of a similar thing. I'm just going to copy and paste this right into here. And then let's say instead of looking at like happiness score, let's look at economy instead. But we still want to see like the country. So I'll keep the country column in there. And then let's say we want to sort by economy as well. And then we want to look at the first 5. So I'll make sure it's head and not tail. And then if we actually run this now and scroll down, it looks like Qatar, Luxembourg, Singapore, Kuwait, and Norway all have the best economy scores. So the numbering here on the left indicates its actual index, which again is based off of its happiness rank. So what's interesting is that places like Qatar and let's say like Kuwait, for instance, are top 5 in the economy scores, but are kind of almost like middle of the rung or kind of a little bit towards the top in the overall happiness index. And of course, we could change this function to tail instead of head to see the worst 5 economy scores on the list. So we'll do .tail. And it looks like we have like Liberia, Malawi, Burundi, Congo, and then Somalia as the bottom 5. And then let's just look at another variable real quick. Let's look at health instead of economy. So let's put health here. And then we'll say, obviously sorted by health as well. Let's look at the top 5. We're doing .head. And then let's go ahead and run it. And if we run it, it looks like, let me double check. Yeah, so it looks like all these top countries, except for Spain, are all from Asia that all have the highest health score. So that's kind of an interesting thing that we can kind of keep in mind maybe for the future. And then let's look at the bottom 5 actually. Let's say .tail. Let's look at these bottom 5 ones. And it looks like pretty much all of these countries are from Africa. So we got Nigeria, Angola, Ivory Coast, Chad, and then Sierra Leone. So that's kind of an interesting thing to look at. There certainly seems to be some sort of correlation here with the region they're in. As we look at, again, like head, these are pretty much all Asian countries besides Spain. And then so these have the highest health scores. Then we look at the lowest health scores, and they all appear to be in Africa. So one thing I actually want to look at real quick is kind of just compare the regions of these scores. It definitely seems like some regions tend to fare better than others in terms of certain variables. So it makes me curious to see what it would look like if we just compared regions completely. So to do that, I'm going to just make a new code block down here. And I'm going to call the group by function that we looked at in one of our episodes. So I'm going to say datasets.groupBy like this. And then we're going to group these together by region. But doing this just by itself won't actually really do anything because we need to do some operation with the data. So I'm going to add .describe like this. And then if we go ahead and print it off, it'll give us a nice describe table like we saw before, except now it grabs all the countries in a particular region and then groups them together. So we have like for one region, Australia and New Zealand, Central and Eastern Europe, Eastern Asia, and so forth. The only issue is that it does this describe function for every single column. And as you can see, these 3 dots here basically show that there's an overflow. So we're missing a lot of this table just because we can't actually see all of it. So just to narrow this down, let's actually just select the happiness score so we don't have all the other variables taking up space. Of course, we'll need to select a region as well if that's what we're grouping by. So to do this, I'm just going to add a double bracket here. And let's get region as well as happiness score. And then now if we run it, it only prints off the happiness score summary for each region, and this is pretty helpful to see actually. However, in our case, let's say we only care about the mean value from this table. So let's actually do something else here. I'll make a new code block, and I'm going to copy and paste this line. But instead of doing describe, I'm just going to type .mean like this. And then if I go ahead and run it, now we have the mean of each region. However, it's not sorted in order, so let's do that super quick. So to sort these actually in order, let's just add another function here. Let's just say sort underscore values, and then we're going to sort it by the happiness score ranking, because that's what our table actually includes. And then we're going to say, same as last time, we're going to do ascending equals false, so we have the highest entry at the very top. So this looks like a super long line of code because we're literally calling like a bunch of different functions on it. So we're first basically just selecting the columns we want, and then we are grouping them by the region. We're getting the mean of each group, and then we're sorting that mean where we have ascending false, so the highest entry will be at the top, and the lowest entry will be at the very bottom. So just so you can see, let's actually run it now. And now it looks like we have a sorted table of which regions have the highest to lowest happiness rating. As you can see, Australia and New Zealand are at the highest, followed by North America, then Western Europe, and so forth, with South Asia and Sub-Saharan Africa being at the bottom. So again, all these numbers are actually showing us is the mean happiness score of each region. Let's say, for instance, we want to keep the same exact sorting scheme, but we want to see the entire data set instead of just these two columns. To do that, we could make a similar code block here, where we could literally just copy and paste this here. But instead of just selecting region happiness score, we can just select the entire data set. So I can just select the entire data set like this, and then I could print it out. And now you can see the mean stats of every single region, but still sorted by happiness score. So obviously we've got happiness score here. That's what determines the ordering. Because it goes 7.32, 7.25, 6.68, and so forth. And then we also have the other mean variables, so like economy, family, health, freedom, and so forth. So just to give us a little bit of help with this, let's actually plot this graph just so we can kind of visualize each region. So I'll make another code block down here, and I'll make a new variable too. I'm just going to set it equal to what we were doing kind of up here with the means and the regions. I'll make a new variable. I'm going to call it mean regions equals dataset. And I'm going to group by regions again. I'll say by equals region. And then all we're going to do is just call the dot mean like this, which if we write that off and then we, let's say, print regions, and we print it off like this. Actually, I can probably just do it like this. Set out a print statement. If we do it like this, you'll see it's the same exact table as the one right here. Although, of course, it's not sorted in any particular order. So next, let's actually use PLT or material plotting library to plot this. So I actually want to do a bar graph. So I'm going to go ahead and just delete this. And I'll show what I'm going to do in a second with the bar graph. So I'm going to type plt.bar. And then remember, with a bar graph, we want to type in the labels as the first argument and then the actual data numbers as the second argument. So for the first one, we need to get the region labels. Unfortunately, we can't just pass in the region column because when you use group by, it doesn't actually classify the grouping variable as its own column, but rather it indexes it by that. So for our labels, we actually need to pass in mean regions like this, and then we need to call .index to get the real labels because technically they are indexed by those titles. So instead of just selecting the region, we just type .index instead, and that'll give us the labels that we need. And then for actual data numbers, we actually can just select the happiness score column. I'm going to do mean regions like this, and then we're selecting happiness score like this because we're basically selecting this whole column here. If you can see like where my mouse is, we're selecting this happiness score column, so we're passing it in as our second argument. And of course, like always, let's add some labels to help us out. So I'm going to write plt.xlabel. Let's call it region. And then plt.ylabel. And then let's call it mean happiness score. And then we'll do lastly plt.title and we'll say mean happiness score of each region. And real quick, looks like we're getting a little thing here. PLT is not defined. Let me go back to the top here. Import Matplotlib. Oh, oops. Should add that as PLT here. So let me actually rerun this because it didn't quite import our material plotting library correctly. Let me reselect this. And then I'll need to rerun the line where we're actually modifying dataset. Dataset.copy, and then let's rename and drop. Okay, so now we should be good. The PLT should be good to go now. So let's go ahead and actually just type plt.show here at the bottom. And then let's go ahead and actually just run it and see what it looks like. And voila, here we have our graph. Obviously, there's one big problem, however, and that's that these region titles are severely overlapping one another, and they make the graph pretty much impossible to look at, and it looks pretty awful and pretty ugly. So there are ways to work around this using some functions, but we're going to take the easy way out and just turn this into a horizontal bar graph instead of a vertical one. So I'm just going to add a bar h right here instead, like this instead of bar, and then I'm going to swap these y labels and these x labels to be a bit more accurate. So I have this like this, and then now if we run it, we can see our graph looks a whole lot better. As you can see, Australia and New Zealand is neck to neck with North America, beating it only by a tiny margin. Then we've got, for instance, Western Europe in third, and then so on. And it looks like, just like we were looking at before with our data in tabular format, it looks like the African regions tend to be towards the very bottom in terms of mean happiness score. Now that we've explored some of the stuff in regards to each individual region, let's actually start looking at some correlation between variables and some predictive analysis. Just like we did with last time, let's use the pair plot function from Seaborn to check out the correlation between two different variables. So below all these graphs here, or I guess I should say the single graph here, I'll make a new code block, and then let's start looking at the Seaborn graph. So I already imported Seaborn as SNS, so I'm going to call SNS and say SNS dots, and then pass in, let's do pair plot, and then pass in our data set that we have here. And then if I run this code here, just like last time, it'll take a minute since there's a lot of computation, but it'll spit out a correlation grid in just a moment. Okay, so I went ahead and fast forwarded a bit, so now we have our pair plot here, and now it looks like we have a ginormous grid, so let's actually sit down for a second and analyze this. So one thing I can note like right away in this pair plot is that if you look at these first two columns, which should be, first one's happiness rank, and the second one is happiness score, that these are practically mirrors of each other. So if you look at like the economy line here, it looks like happiness rank and happiness score are exact mirrors, and then same with family for happiness rank and happiness score. Hopefully this makes sense why it's like that, and that's because the happiness score directly impacts the happiness rank of a country. So the reason they are mirrored is because they're pretty much inverses. So in a ranking system, 1 is considered the highest, and the higher the number, the worse rank you are, technically, numerically, whereas in the score field, a higher number is better. This means that a high happiness score correlates to a numerically low happiness rank. So for example, I believe it was Denmark that had the highest overall score, means they technically have the lowest overall rank numerically, even though it's rank 1, which stands for the best. So in terms of actually looking at our correlation analysis and trying to find some graphs that might work, I think the variable I really want to look at here is happiness score. We could use happiness rank too, but score offers, I think, like a more kind of just definitive and specific number that we can measure. So because of this, we want to find graphs in this pair plot where the happiness score is on the y-axis so that it is the dependent variable, which means I kind of want to look at ones here in the second row, which has happiness score as the dependent variable. So let's actually scroll down and see which columns are which. So we got economy, family, health, freedom in that order. Then if we go back up to our happiness score here, it seems to me that economy and health are the two most correlated with happiness score. So what I mean by that is this: if you look at the second row here, the third column from the left and also the fifth column from the left appear to be the most correlated. It looks like family is definitely correlated as well, but maybe not as strong, maybe not as heavily as economy and health are. So let's just go ahead and keep these three graphs in mind here when we dive further into some correlation exploration. And so by those three graphs, I just mean in this second row here, the third, fourth, and fifth columns here. One thing I'm realizing as I'm looking at this is that it seems like things like economy, family, and health are all generally positively trending together. So if you look at the rows between economy and health, which should be like economy on this y-axis here, and then health on this axis, so it's the fifth column over in this third row here. This tends to be, or this actually looks like quite a positive and like tight correlation. So even though this data set is meant to explore happiness rankings of countries, we could also use it to explore some of the other factors that impact each other, like these variables like economy and health, for instance. So for example, maybe we could ask, how does a country's economy affect the health of its citizens? In fact, if we look at the intersection of health on the y-axis, where we have health here, and then economy on the x-axis, which should be this third one here, looks like there's actually a very tight correlation between the two, suggesting a good economy may lead to stronger health numbers. So now let's do the same thing we did with our last data set and use this pair plot function to help us plot out some individual charts. So there's actually three correlations I want to look at in more detail here. So I want to look at the correlation between economy and happiness. So let's go up here. So economy and happiness is 1. I want to look at the correlation between health and happiness, and also the correlation between economy and health. So I'm going to go actually below this. I'm going to make 3 new code blocks for each one of these graphs that I want to explore, just like this. So in this first code block, I want to make a scatter plot between economy and happiness score. I'm going to write plt.scatter. I'm going to pass in both of our columns here. So for our x column, we want to have economy because that's our independent variable. And then for our y value, or our independent variable, or sorry, OS, I said that backwards, sorry. This economy is our x variable, so our independent variable. And then we want to have our dependent variable as happiness score. That should be like this. And then if we actually, oops, extra quotes there. And then if we run it, we can see we just reproduce one of the graphs on the grid with economy on our x-axis and happiness score on our y-axis. And just like every other time, let's make some labels. Let's say plt.x label, label economy, plt.y label. Let's just label this one happiness score. And then let's of course type plt.show. And then let's just run it like this, just to get a little bit nicer formatted. And now let's look at our other 2 correlations. So I'm going to copy and paste actually this line here into our other 2 blocks, and then we can just change the variables around. So in this one right here, let's see, I want to look at the correlation between health and happiness score first. So I'm going to do health right here. And then in this block, I want to change it to economy and health. So I'm going to say economy and health like this. So basically, we're looking at how health affects overall happiness and how the overall economy affects overall health. So let's go ahead and just run both of these and get both the scatter plots for each of these. So we get a scatter plot here between health and happiness score, and then also a scatter plot here between economy and health. And actually, real quick, I'll just take this stuff up here, just copy and paste it, and I'll change the labels to match. So I'll do paste that in, paste that in. For this one, this is the one that's looking between health and happiness score. So I'm going to say health here for the x-axis. And then for this one, actually, I'll run that real quick. Showing us some nice labels. And then this one, it's economy and health. So I'm going to change this one to health just to match the columns that we're actually picking. So now we have labels on this one as well. So as you can see, if you look at all three of these graphs, it looks like all these graphs have a somewhat decent degree of positive correlation, meaning they move up diagonally together. So let's actually see what the correlation is by performing a linear regression on all these variables. We'll do each one individually and see what we can come up with. So first, I actually want to focus on this very first correlation here, and that'll be economy as the independent variable and happiness score as the dependent variable. So I'm going to go down here. Let's actually make a block kind of down here for our linear regressions. So to set our x and y variables, remember we need a numpy array when making these. So for our x variable, I'm going to make it a numpy array. And then all I want to do here is pass in our economy column. So I'm going to say dataset economy. And then remember, we need to reshape it so it is like a column and not just a row. So we'll say reshape -1 to 1 like this. And then we'll do the exact same thing for y. Because I'm lazy, I'll copy and paste it. We'll say y equals numpy array. Instead of economy, we want it to be happiness score like this. And then we're still reshaping it 1 to 1 like this. And then next, we need to get our training and testing splits. So I'm going to copy and paste the same line from the last episode just so we can get this out because I am kind of lazy. So I don't need to type out the entire line. So I'm going to print this out. This is the line, again, like I said, that will split up our training and testing sets and then split up the x and y variables based on what we pass in. And then we can set in the testing side, which is 20%, which means the training size should be 80%. Next, we want to actually make our linear regression model. So we'll do that same as last time. We'll say linear equals, and then we'll call our linear model module that we imported in Sklearn. Let's call .linear regression, as this will actually make our linear regression object. So all we're doing is calling Sklearn's linear model library and then accessing this linear regression object. And then lastly, we want to actually train the model, which to do that, just like last time, we'll type linear.fit. And then all we need to do is pass in our training values for both x and y. So let's say xtrain and then ytrain. And then if we actually run this code chunk now, we now have a working linear regression model for economy and happiness score. So let's go ahead and see what our coefficients and our slope is. I'll make a new code block down here, and I'm just going to print it off. So I'm going to print, say, linear.coefficient like this. And then I also want to print off our intercept. So I'm going to print linear.intercept like this. And then just like last time, I'll kind of format it a little bit nicer, actually. We'll do, so let's say, slope / coefficient like this. And then we'll have a comma there to separate it out. And then on this one, we'll just say y intercept, and then a comma like that. And then if we actually run this now, you'll see that it gives us the slope of our line and our y-intercept. So again, if we translate this to our y equals mx plus b format, like we have a line equation that's like this, we have y equals mx plus b. What this means with this slope and coefficient is that our equation for our linear regression model we just made would be equal to y equals 2.2 approximately, because I'm rounding, x plus 3.25, because 2.2 is our slope, which is our b value, and then 3.25, it's our slope, which is our m value, and then 3.25 is our b value, so our y-intercept. So next, just like last time, let's take a look at what our score actually is, so we can see how good our model actually is at predicting these. So I'll make a new block, and I'm just going to type linear.score, and then to score it, we just need to pass in our testing variable to see how good they actually did. So we'll do x test and then y test. And then if we run this here, you can see that we got a score of approximately 0.706. So this is actually a fairly decent score, showing that basically if we were given the economy, we could predict the happiness score somewhat confidently about 70% of the time. So just like how we did before, we look at the different training and testing sizes. And of course, because this function randomizes it, the score can vary each time. So let's actually remake and retrain our model up here. And let's run this score again. This time you can see it's decent, quite a bit worse actually. It's 0.587. Let's just do it again. And I'll just do it a few times. Actually, it's getting kind of worse. I'll do it a few times just so you can see kind of what the score varies to. That's 0.59, 0.57. It looks like it's actually kind of staying around that area now. If we want to see a bunch of times running this, we could see kind of the average score over time. Looks like we might have gotten lucky with our first score having it kind of decent. Let's just run a few more. Let's just say like one more after this. And that one is a pretty low score, gave us 0.38, but we'll have to do with it for now. So the reason why it varies so much is because this is such a small data set, and it only has like 150 entries in it, whereas a lot of data sets you're going to find might have like millions or just thousands. So theoretically, there should be a lot less variance if you have like a ton of entries, but because we don't have that many, there's not really a whole lot of testing and training we can actually do on this model, so it is kind of bottlenecked by that just a little bit. And I actually don't want to get a score this low, so I'm going to run it like a couple more times, see if I can get something a little bit higher. Let's settle. Okay, that's decent so far. We'll stay with this 0.63 score. So let's roll with this score in this model, and let's use it to actually make predictions for what our happiness scores should be, so we can compare them to what our actual values are to see how accurate our model is. So I'll make a new code block here to actually make our predictions, and so we can print them out. I'm just going to say, I'll just name it predictions. I'll say predictions equals linear.predict. We're just calling the predict function off the linear regression object. And if we want to pass in our x testing values, and basically x values, it will predict the y values. So just like we did with the last time, we'll make a loop that prints off all of our actual values versus our expected values. If you had a huge data set, you wouldn't want to actually run through a loop and print out everything because there'd be a lot of entries and it'd be kind of tedious to do. But since we have a pretty small testing set, it's fairly small and it actually shouldn't be a problem. So to make a loop, all we'll do is say for x in range, and we'll do length predictions, because we're just looping through every single prediction we've made. And then what do we actually want to do inside the loop? We just want to print off our actual value versus our predicted value. So I'm going to print off the actual value first. I'm going to say actual value, and then comma, and then we want to get the y-test value, because that's our actual value we have for our testing set. And then we will say our predicted value, and then that will be our actual prediction value, like this. And so if we were to actually run this code, it now gives us a list of all the values we actually got versus the values we predicted we would get. And of course, our model certainly isn't perfect. However, it does appear that these predicted values are somewhat in the ballpark of the actual values, showing at least some decent degree of correlation. So for example, we can look at, for instance, like this value here. Let's say we have an actual value of 7.119, but the prediction that our model made was that it would be 6.462. So they're not perfect, but they aren't too wildly off. And of course, it should be noted that all these values that are being predicted and looking at actual are happiness score, because we selected happiness score as our dependent variable. So these are all happiness scores, whether they're actual or predicted or not. So let's look at more, for instance, like we have, this one's pretty close here. We have 6.379 actual value, where it had predicted that was 6.347. So pretty close. We can go through each one of these and kind of see that our guesses aren't actually too wildly off. So let's go ahead and plot this regression so we can see what it looks like visually. Just like the other chunks that we've been doing, I'll pretty much be copying and pasting everything that I have written from the previous episodes. One of the really nice things about data analysis is that once you have the code written and know how to do like something, then if you ever need to do that thing again in the future, you can just come back and copy and paste your original code. So in a new code block, let's set up our actual graph. I'll make it here, and now we can set it up. So I'll make our original points a scatter. So I'll say plt.scatter, and we want to pass in our training values because this is like the bulk of our data set. I'll say xtrain and then ytrain. And then we want to plot the line of our regression. So to do that, we'll do plt.plot like this. And we're going to pass in the x values for happiness score, and then also the predictions. So, or sorry, these are x values for economy, not happiness score. And then we have our predictions here, which will be for happiness score. And then just like we did in the last episode, we want to make our line extend to both ends of the graph so it doesn't just stop abruptly. So to do that, we're going to call plt.axline, and then we're going to set our intercept coordinate to the intercept, which should be 0, and then a float of our intercept, like this. And then we would like our slope argument to also be equal to a float, and that's just going to be the coefficient / slope like this. And it'll probably help if I spelled linear right. It might be a little bit better. Okay, and then of course, as always, let's add our labels. We'll do plt.x label is economy, plt.y label is happiness score, and then we'll make plt.title equal to happiness score versus economy. And then at the very bottom of this, we'll type plt.show. And then let's actually run this now and see what we got. So if we run this, we now have a solid linear regression graph. The points represent the scatterplot of our training data, which is meant to represent the majority of the entries, and the line represents our model or our linear regression model, which is meant to follow the trend that minimizes the variance of these points. And you can see, I think it does a pretty good job of actually minimizing them, because it looks like this line tends to follow the trend of these dots fairly well. Now that we have this graph, let's look at a few other linear regression models, which we'll get through a little bit quicker. Let's just go up here, actually to the very top where we trained it and tested it. Let's actually just change one aspect of it. Instead of using economy, let's use health. So in this sense, we'll be looking at how health can impact the overall happiness of a country. So I'm actually just going to change this here to health like this. And then let's run it and run all the blocks below it. So I'll run it, actually make our model and train it. Let's print off our line here. I'll just change this here. So this new slope would be, let's see, we have 3.81 like this, plus 3.28. So that'll be our new linear regression line using health instead of economy. And then I'll run this to get our new score. Let's see, our score is a little bit lower, which is okay for now because we'll look at that in a second. And then let's just run our predictions again. And here we go. Here is our table of predictions. And then let's actually just print this off here like this. And I'll also want to change these X labels and Y labels to actually match what we're doing, and same with the title. But actually, I might do a quick improvement here. Here's actually what I'll do. So I'm going to go back up to the top here, and I'm going to make a variable. I'm going to call it xvar, set it equal to, actually I'll do xvar and yvar. So we have both of these. And then I'll just store health in this one, and then happiness score in this one. And the idea with doing this is that if we want to change the variables, we don't need to change them in every single field, like changing them in here and then also labels and everywhere else. We can just change it up here and then plug this variable in for every time we reference. So now instead of passing in strings for all these, let's actually pass in this variable anytime we want to use it. So here we're going to pass in xvar. Here we're going to pass in yvar. Let's go down a little bit. Looks like we don't reference it here. And then we want to pass in for our x label, we want to have xvar. Y label, we want to have yvar. And then obviously for our title, we want to have something, actually let's just remove these here. I'll do something kind of neat here. I'll just do, let's say yvar plus, then versus like this, and then plus xvar like that. And then so the idea with this is that if we were actually to go up here and just run this block now, retrain our model, let's rerun everything real quick, get scores again, get predictions again, and then run our graph now. We don't need to worry about having to change the labels by hand because we just stored them in these yvar and xvar variables. So now they're super easy to access and change whenever we want. So we're just changing one line instead of like 50. So if we look at this graph and compare it to the graph we had versus economy, it appears that this actually is pretty similar to our economy graph with a fairly tight fit and positive correlation between the two variables, that being happiness score and health. I want to look at one last correlation though, and that's the correlation between economy and health. In this case, we want economy to be our x variable and health to be our y variable. So let's change that up here. Let's say economy for our x variable, and then we will have health for our y variable. And then let's all run these, or run these all again. Run this here. Let's get our score. We got 0.61. Let's run our predictions, and then let's run our graph here. And now we have health versus economy. It seems pretty clear based on our score in this graph that there actually does appear to be a pretty strong correlation between the two of these variables, being health and economy. And it appears, again, like our score here is 0.61, which is not like amazing, but it's definitely not bad either. So it definitely is some sort of positive correlation between these two variables. So basically, in conclusion of all these simple linear regressions, what do all these say about our data set? Well, it says that a country's economy and health scores are likely the two biggest influencers of a country's overall happiness scores. And also, we found that a higher economy score is generally correlated to a higher health score for an individual country. So let's look at one last thing before we wrap up this video. Let's take a look at a multiple linear regression with more variables than one. So let's actually go back up here where we're making our model and training it. And let's modify the x variable here. So let's change our y variable back to happiness score real quick. We want to look at happiness score. And then let's think about what x variables we want to actually include in our multiple regression. I'm thinking since we went over economy and happiness, we should combine those two together Then also add in family, because if we look at our Seaborn plot here, go up, if we look at, so economy, family, and health are these three columns side by side, so columns 3, 4, and 5. If we look at their correlation with happiness score, they all appear to be pretty heavily correlated, at least reasonably. So let's actually combine those three in a multiple linear regression. So I'm going to go back down here to our model. Then I'm just going to make our xvar a list instead of just one string. So I'm going to say, have it be economy, health, and then family like this. So now we're basically combining the economy column, the health column, and the family column, all to predict the happiness score. And then the only change I need to make to this is to get rid of this reshape function, because we only need to reshape if it's one dimensional, but it's not since we're selecting multiple columns. So now let's actually train and run this model. Let's run it here. Now we've made our linear regression. Let's look at our coefficients at intercept. So we have 3 coefficients here. Obviously we have one for each variable. So this would be our coefficient for economy. This would be our coefficient for health, and this would be our coefficient for family. And then, of course, like usual, we have our one y-intercept value. Let's look at the score now and see what we got. Okay, so nice. We got a score of 0.768. So that is actually the highest score I believe we've gotten so far with all of our models. Let's actually run it a few times just to see kind of what the average score is. So we got 0.76, we got 7.380, that's nice. 7.6, 7.1, and okay, that one's a little bit lower. 4.8, that one's really low actually. It's getting lower and lower. Let's see, that's 0.68. Okay, so actually if you notice that whenever you run it over and over, it seems that the average score seems to generally be higher than that of a simple linear regression model. This is generally the case when we add more variables into the mix because it gives our model more data to train on, and it looks like this multiple linear regression model actually is more accurate than the simple ones we've gone over so far. And that pretty much sums up everything we're going to cover in this video. Just like last time, I'll do a simple kind of analysis of this data set and kind of what the conclusions we've come to are. So basically, looking at the data set with the World Happiness Index, it appears that the variables of economy, health, and family are the 3 most strongly correlated to the overall happiness of a country, where it looks like economy is probably the overall highest correlated on its own, and then there also appears to be a correlation between economy and health, for instance. When combining the variables of economy and health and family together in a multiple linear regression, it looks like those 3 are the best predictors of the overall happiness score. So something like that with what I just said would be a nice little succinct way to kind of summarize the data set and kind of summarize your findings using some analysis and predictive modeling. And that's going to officially wrap up this course for you guys. I really hope you're able to learn a lot about data analysis, and I hope that this course was comprehensive enough to at least give you started on your way. Give yourself a pat on the back if you've gotten this far, because this stuff isn't always easy and can be challenging and intimidating at times, so I certainly respect it if you've gotten this far in the course. In the future, I'll be making more courses like this, so if this kind of stuff helps you out, please subscribe and I'll keep pumping this stuff out for all you guys to see. Take care everyone, and hopefully I'll see you in my other videos. Peace out.